The question is a soft normally consolidated clay layer is 10-meter thick. 10-meter thick with a natural moisture content W is given 45%. The clay layer has a saturated unit weight. Gamma saturated is given as 19 kilonewton per cubic meter. The specific gravity is given as 2.65 and liquid limit is given as 0.65. A foundation load will be subjected at the center of the layer to a vertical stress increase delta sigma. Vertical stress that is increased at the center is given as 10 kilonewton per square meter. What is the settlement of the foundation? If the groundwater level at the surface of the clay layer, the groundwater level is at the surface, so we have to find out the settlement we have to find out. We know the settlement for a normally consolidated clay. Settlement is equal to Cc by 1 plus E naught into H log base 10 sigma naught plus delta sigma by sigma naught. So what are the factors that we know is only H 10 meters. We have to find out E naught. Cc we have to find out from the given data. Delta sigma is given 10. We have to find out sigma naught at the center. So unknown parameters are Cc, E naught, sigma. So Cc, how we are going to calculate Cc? There is a relationship, consolidated compressive index Cc is given by 0.009 into liquid limit minus 10 for a normally consolidated clay. So by substituting these values, 0.009 liquid limit is given as 0.65, that is 65 minus 10. That implies Cc we are going to get 0.495. E naught we can calculate initial void ratio E is equal to Wg by Sr. We know the relationship, but Sr is going to be 1 because of fully saturated. The water table is at the top of the clay layer. So W, we know the water content is 0.45 into the specific gravity is given as 2.65. That is equal to 1.1925. We know the void ratio. So sigma naught, the vertical effective stress at the center of clay layer is equal to gamma saturated is given minus gamma W into H is H by 2, that is gamma saturated 19 minus, we can take it as 9 or 9.81 into 10 by 2, that is equal to 45.95 kilonewton per square meter. So final effective stress, by substituting these values on in the above equation 1, we are going to get Cc is equal to 0.495 into 10 divided by 1 plus 1.1925 log base 10 into sigma naught is sigma naught plus delta sigma. We can directly write it as 55.95 divided by 45.95, that is equal to 190 mm. 190 mm, option B is correct. In a cylindrical sample of soil having a cohesion of C is given as 0.8 kg per centimeter square and the angle of internal friction is 20 degrees, phi is given as 20 degrees, is subject to a cell pressure of sigma 3, cell pressure 1 kg per centimeter square. What is the maximum deviatoric stress? We have to find out maximum deviatoric stress, that is equal to sigma 1 minus sigma 3. So we have to find out sigma 1. Sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. By substituting sigma 3 and phi in this equation, sigma 3 and phi and c, we are going to get sigma 1 is equal to 4.3246 kg per centimeter square, and we have to find out the deviatoric stress. So sigma d is equal to sigma 1 is 4.3246 minus sigma 3 is 1, so 3.3246 kg per centimeter square. So option C is correct. Question is, when 1 liter of activated sludge containing 6000 milligrams per liter of MLSS occupies a volume of 300 ml, setting for 30 minutes in a measuring cylinder, it can be assumed that the supernatant is clear of suspended solids. What is the sludge volume index? Sludge volume index we have to find out. So we know the sludge volume index is equal to Vs by Xt, where Vs is the volume of solid that are settling. Solids containing 6000 milligrams of MLSSV. So that is equal to volume of the solids that is settling. Volume of the solids 300 ml. 300 ml, that should be in ml, and it should be in grams per liter, ml per liter. So ml per liter 6000 into 10 to the power minus 3 milliliters per gram, that is equal to 50 milligrams milliliters per gram. So option A is correct. Question is, the radius of a horizontal curve r is given as 200 meters. The design speed v is given as 80 kmph, kilometers per hour, and the design coefficient of lateral friction f is equal to 0.15. What should be the rate of super elevation? E we have to find out. If the full lateral friction is considered, we have full lateral friction has to be considered. So we know the relationship for the super elevation and friction, v square by 127 r. Here v is in kmph. So E is equal to V square is 80 square 127, R is in meters 200 minus 0.15, that is equal to 1 in 10 E. So option C is correct. A circular primary clarifier processes an average flow of 4800 cubic meters per day. So average flow is given as flow Q we can consider is equal to 4800 cubic meter per day of municipal waste water. The overflow rate is given as 30 cubic meters per square meter per day. So we have to calculate the flow area, the diameter of the clarifier. We have to calculate the diameter d of the clarifier. So flow area is equal to average flow Q by overflow rate, that is equal to 4800 cubic meter per day by 30 cubic meter per square meter per day. So that is equal to 160 square meters. Flow area pi by 4 d square is equal to 160 square meters. D is equal to 14.27 meters, that is equal to 14.3 meters. So option D is correct.